Japan's best pilots had never seen anything like this, the P-38 Lightning that ended their dominance. In 1944, a Japanese Zero pilot named Saburo Sakai, one of the greatest aces his country ever produced, a man who had been fighting since China in 1938 and had survived being shot through the head, wrote in his flight log a single sentence that summarized the feeling spreading through the entire Imperial Japanese Navy air arm. The twin-tailed devil cannot be caught. He was describing the Lockheed P-38 Lightning. And he was right. For 13 months after Pearl Harbor, Japanese fighter pilots had owned the Pacific sky. Their aircraft, their tactics, their training, all of it had been tuned to a doctrine of horizontal maneuver combat that no Allied pilot could survive. The Mitsubishi A6M0 had a turning radius of 950 feet. It could climb to 6,000 feet in under 7.5 minutes. At close range, in a wheeling dogfight, it was essentially unbeatable. American pilots flying Bell P-39 Airacobras and Curtiss P-40 Warhawks had learned this through attrition, through the deaths of friends who tried to turn with a Zero and found themselves on the wrong end of a 20mm cannon. Then, in the dawn hours of December 27, 1942, 12 twin-boom Shadows lifted off from a steel-matted airstrip at Port Moresby, New Guinea. Within 45 minutes, Japanese naval aviation's 13 months of dominance had ended. Not faded. Not gradually declined. Ended. In a 10-minute engagement over Buna that left 12 Japanese aircraft in flames and exactly 0 P-38s destroyed. The pilots who survived that engagement filed reports that reached Imperial Japanese Navy headquarters in Rabaul and created something those headquarters had not seen from the air arm since 1941. Panic. This is the story of how a twin-engine fighter from a drawing board in Burbank, California shattered the most capable air force in the Pacific, killed Japan's greatest admiral, and permanently rewrote the rules of aerial combat. To understand what happened over Buna on December 27, 1942, you have to understand exactly how good the Zero was, and exactly how much American pilots had suffered against it. The Mitsubishi A6M0 had been designed to an Imperial Japanese Navy specification that, when American engineers first read it after the war, they initially assumed must be wrong. The Japanese Navy had asked for a carrier-based fighter with a maximum speed above 500 km per hour, a climb rate that could reach 3,000 meters in 3.5 minutes, a turning radius tighter than any other fighter in the world, and an operational range of over 1,600 kilometers. American engineers believed you could have 2 of those 4 requirements. The Japanese got all of them by ruthlessly stripping every gram of weight from the airframe. No pilot armor, no self-sealing fuel tanks, structural members shaved to the minimum. The Zero weighed 1,680 kilograms empty. The Curtiss P-40E that opposed it weighed 2,880 kilograms. The result was an aircraft that seemed to violate physics. Turning radius of 950 feet, tighter than a Spitfire, tighter than a Hurricane, tighter than anything American factories were producing. Climb rate to 6,000 feet in under 8 minutes. Maximum speed of 331 miles per hour at altitude. Armament of 2 20mm cannons and 2 7.7mm machine guns, heavier than most Allied fighters of 1941. And that range, 1,600 kilometers, that meant Japanese carrier pilots could operate far beyond where American planners thought any carrier fighter could possibly reach. Pearl Harbor had proven that in the most violent way possible. The men who flew the Zero had been flying since China, some of them since 1937. They had accumulated thousands of hours in combat against Chinese, Dutch, British, and American aircraft. The cream of them, the pilots who had launched from the Kido Butai on December 7, 1941, and the men who swept through the Dutch East Indies and Malaya, were arguably the most combat-experienced fighter pilots on Earth. They had never encountered a serious opponent. American pilots were not cowards. The men flying P-40s over the Philippines and P-39s over New Guinea flew into combat knowing the odds were against them. And kept flying. But the physics of the situation were merciless. A P-40 pilot who made the mistake of entering a turning engagement with a Zero was already dead. He just hadn't landed yet. The Zero would simply spiral tighter and tighter until it was on the American's tail, and then it was over. Standard survival tactics for P-40 pilots had been reduced to this: dive away, use the P-40's superior diving speed to escape, do not, under any circumstances, try to turn. By the end of 1942, American fighter pilots in the Pacific had accumulated a body of hard-won tactical knowledge that boiled down to one sentence: to survive against Japanese fighters, you had to refuse to fight them on their terms. The P-38 was the first American fighter that gave its pilots an alternative set of terms to offer. Lockheed's Clarence Kelly Johnson hadn't set out to revolutionize aerial combat. He'd been given a set of performance requirements by the Army Air Corps in 1937 that seemed, frankly, impossible. A pursuit aircraft with a top speed exceeding 360 miles per hour, a range of over 1,000 miles, and a service ceiling above 40,000 feet. Every single-engine fighter of 1937 fell short of at least two of those requirements. Johnson's solution was to stop thinking about a single engine. The XP-38 prototype first flew on January 27, 1939, and it looked like nothing else in the sky. Twin Allison V-1710 engines buried in streamlined booms that extended back to twin-tail fins, the pilot seated in a central nacelle between them. The configuration was born from necessity. Two engines were needed to achieve the required performance, and the twin-boom layout was the cleanest way to mount them while keeping the propellers from torquing the aircraft into an uncontrollable spin. What Johnson had built, almost as a byproduct of solving these engineering problems, was a fighter with capabilities that didn't fit any existing tactical doctrine. Twin Allison V-1710 engines, each producing 1,150 horsepower, 2,300 horsepower total, more than almost any single-engine fighter of the era. Turbo superchargers on each engine that maintained sea-level power output at altitudes where normally aspirated engines were gasping for breath, losing 50% of their output above 20,000 feet. Maximum speed of 414 miles per hour, 83 miles per hour faster than the Zero. Service ceiling of 44,000 feet. And armament concentrated in the nose where the laws of ballistics worked in the pilot's favor. One 20mm Hispano cannon and 4.50 caliber Browning machine guns all aimed in exactly the same direction, without the convergence problems that plagued wing-mounted weapons on other fighters. A P-38 pilot didn't have to calculate a convergence point. He pointed the nose at the target and pulled the trigger. The aircraft had one other advantage that wouldn't become tactically relevant until pilots understood how to exploit it. Its twin engines gave it emergency power reserves that single-engine fighters couldn't match, and its range with drop tanks exceeded 1,000 miles, enough to fly escort missions that American planners had previously considered impossible. The pilots who first took the P-38 into combat over New Guinea in late 1942 were not, initially, sure what to make of it. The aircraft felt alien to anyone trained on conventional fighters. Its counterrotating propellers eliminated the torque effects that required constant rudder pressure in other aircraft. The controls were light and responsive in ways that felt unnatural. The turbo superchargers made sounds that new pilots found alarming until they learned that the sounds were normal. And the aircraft's behavior at high speed, the way it settled into rock-solid stability as it accelerated past 400 miles per hour, was unlike anything in the Allied inventory. Richard Bong understood what he had the first time he flew it. A farm boy from Poplar, Wisconsin, who had learned to fly through the civilian pilot training program and had flown loops around the Golden Gate Bridge during training, earning a formal reprimand, Bong grasped the P-38's tactical implications with an intuitive clarity that his superiors would spend months trying to articulate in official training manuals. The Zero could outturn the Lightning. In horizontal maneuvering combat, the Zero would win almost every time. Therefore, the answer was never to fight horizontally. Speed. Altitude. A diving attack from above, using the Lightning's turbo-supercharged performance to hold a position that the Zero literally could not reach. One pass, precise gunnery from longer range than Japanese pilots expected to face, and then a climb back to altitude using energy that the Zero couldn't match. Not a dogfight. A vertical hunting operation. The question was whether it would work in actual combat. On December 27, 1942, 12 P-38s answered that question. The morning briefing at Port Moresby had been urgent. Coast watchers, Australian civilian volunteers who had stayed behind on Japanese-occupied islands to radio intelligence reports, had reported a major raid developing. Approximately 40 Japanese aircraft, mixed types, approaching Buna. Fighter escort confirmed. 30 minutes to intercept. Captain Thomas Lynch checked his instruments and signaled his 12-aircraft formation. Among his pilots was Second Lieutenant Richard Bong, temporarily attached from the 49th Fighter Group's 9th Fighter Squadron, while that unit waited for its own P-38s to arrive. Lynch's briefing had been simple: climb to 18,000 feet, hold altitude advantage, attack from above. The Japanese formation approaching Buna was formidable. Mitsubishi A6M0s and Nakajima Ki-43 Oscars flying escort for Arichi D-3 Aval dive bombers, the same combination that had devastated Allied shipping and airfields across the Pacific since December 1941. The pilots flying those escorts were veterans of the New Guinea and Solomon Islands campaigns. They had accumulated hundreds of combat hours. Several had kill tallies that American pilots would have considered exceptional. What they hadn't done was fight a P-38. At 18,000 feet, Lynch's formation had every advantage. The turbo superchargers were maintaining full power at an altitude where the Japanese fighters' engines were laboring. The Lightning's diving speed exceeded 400 miles per hour and was still climbing as airspeed built in the dive. And the nose-mounted armament gave the P-38 pilots an effective range that Japanese fighter doctrine hadn't anticipated. Lynch pushed his control column forward. The attack took 10 minutes. In those 10 minutes, the 12 P-38s of the 39th Fighter Squadron claimed 12 Japanese aircraft destroyed. Lynch himself killed an Oscar in the opening pass. The Japanese fighter simply disintegrated under the impact of 20mm shells and .50 caliber bullets delivered at a combined closing speed that exceeded 600 miles per hour. As Lynch climbed back to altitude, Zero pilots attempted to follow, pushing their throttles forward in dives that their aircraft had never been designed to make. Warning indicators lit up in Japanese cockpits as the airframes approached their structural limits. The Zero had never been stressed for high-speed dives. Its light construction, so perfect for low-speed maneuvering, became a liability at velocities the aircraft wasn't designed to survive. Bong scored his first 2 kills in this engagement. He spotted a Zero attempting to intercept Lynch during the climb-out, rolled into a deflection shot, and his burst found its mark. The Zero spun into the jungle. He pulled up from the attack and immediately had 3 Zeros converging on his position. His response was entirely correct and would have been suicidal in a P-40 or P-39. He pushed the throttles forward and dove away. By the time the Japanese pilots responded, the P-38 was accelerating past 450 miles per hour and pulling away. The Zero pilots watched the twin-boomed fighter simply disappear, not break off the engagement, not turn away, but literally vanish into the distance at a speed they had no physical means to match. Pulling out of his dive just above the jungle canopy, Bong spotted a Val dive bomber recovering from its attack run. He was close, 100 yards, and the burst was short. The Val hit the jungle in a ball of orange fire. 2 confirmed victories. The beginning of what would become 40. Zero aircraft. P-38 losses. The Japanese after-action reports, captured years later, expressed something that hadn't appeared in Imperial Navy aviation documents since the war began: confusion. Pilots described aircraft with impossible speed and climbing ability. They described being attacked from ranges beyond normal combat parameters. They described pursuing American fighters that simply refused to slow down and fight, that converted every attack into a diving escape that left Japanese aircraft hopelessly behind. The comfortable world of horizontal maneuvering combat, the world in which Japanese pilots were supreme, had been replaced by a 3-dimensional battlefield where altitude and velocity counted for more than turning radius, and where the Japanese had neither. This single engagement sent shock waves to Rabaul. What followed December 27th was not an immediate, uniform collapse of Japanese air power. It was something more systematic, a tactical reckoning that unfolded over weeks and months as Japanese commanders attempted to develop counters to an aircraft that seemed to negate everything their doctrine was built on. The fundamental problem was geometric. A Zero could outturn a P-38 in horizontal combat. But could outturn only meant something if you could get the P-38 into horizontal combat. And a P-38 pilot holding 18,000 feet with his turbo superchargers maintaining full power had no obligation to come down and fight on terms that favored his opponent. The numbers were unforgiving. The Zero service ceiling was nominally 33,000 feet, but the aircraft's engine was normally aspirated. No turbo supercharger to compensate for altitude. Above 20,000 feet, a Zero's engine was producing perhaps 60% of its sea level output. Climb performance degraded. Maneuverability degraded. Maximum speed degraded. The aircraft that had swept through the Pacific at low and medium altitudes was struggling at the altitudes where P-38 formations preferred to operate. Squadron commanders in New Guinea and the Solomons codified this advantage into tactical doctrine with evangelical fervor. Altitude is life insurance became a mantra repeated in every briefing. Speed is life was painted on bulletin boards. Pilots who went down low to chase Japanese fighters, who abandoned their altitude advantage in pursuit of kills, were not congratulated when they returned. They were pulled aside and told, quietly and firmly, that they had just gambled their lives for nothing. The high-speed yo-yo became the standard P-38 attack profile. Start from altitude with a diving attack that built speed to over 400 miles per hour, fire at ranges where Japanese pilots didn't expect to be engaged, then use the accumulated energy to zoom climb back to altitude in a maneuver that the Zero simply couldn't follow. By the time a Japanese pilot completed his rolling reversal to pursue the climbing P-38, the Lightning was already 5,000 feet above him and accelerating. Japanese responses were tactically ingenious and ultimately futile. They instructed pilots to stay high, to attempt to match the P-38's altitude advantage by climbing before engagement. But the Zero's engine couldn't maintain power at 25,000 feet, and P-38 formations were increasingly holding 28,000 to 30,000 feet. They tried flying combat spread formations designed to make it difficult to pick off isolated aircraft. The P-38s responded with coordinated element attacks, 2 aircraft working in concert, one to draw fire while the other struck. They tried luring P-38s into low-altitude turning engagements by flying bait formations of apparently vulnerable aircraft. Experienced P-38 pilots recognized the trap. If a Japanese fighter appeared to be flying alone and slowly at low altitude, something was wrong. New Japanese aircraft appeared in an attempt to close the performance gap. The Kawasaki Ki-61 Tony had a liquid-cooled engine and heavier construction than the Zero, specifically designed to engage high-altitude American aircraft. It was faster and could dive more aggressively than the Zero without structural risk. Pilots encountered it with initial concern. After several engagements, they relaxed. The Tony was better than the Zero at altitude, but still fell short of the Lightning's performance above 20,000 feet. The Nakajima Ki-44 Shoki emphasized speed and climb rate over maneuverability, sacrificing the Zero's famous turning ability for straight-line performance. Against P-38s, it was closer, but still not close enough. Intelligence summaries from Japanese units captured in 1943 and 1944 reveal a pattern of progressive demoralization that is remarkable given the combat culture of the Imperial Navy Air Arm. Units were being instructed to avoid combat with P-38s unless holding overwhelming numerical superiority and altitude advantage. Even then, engagement was discouraged above 15,000 feet. Some pilots were writing to family about nightmares featuring twin-boom shadows diving from unreachable heights. Others were requesting transfers to ground units. The Imperial Navy's elite fighter force, the force that had not lost a major engagement in the first year of the war, was experiencing something it had no cultural framework for processing. It was losing. On April 13, 1943, American codebreakers at Station HYPO in Hawaii intercepted a message that would enable one of the most consequential single missions of the Pacific War. The message, sent in the JN-25 naval code that American cryptographers had been reading since before Pearl Harbor, outlined an inspection tour by Admiral Yamamoto, Commander-in-Chief of the Combined Fleet. Yamamoto planned to fly from Rabaul to Ball Island near Bougainville on April 18, visiting forward air bases to boost morale among pilots who, the message didn't say but everyone knew, were struggling against American air power. The itinerary was detailed to the minute. Departure from Rabaul at 0600, arrival Ball at 0945. 2 Mitsubishi G4M Betty bombers carrying the Admiral and his staff, escorted by 6 Zeros. The intercept went immediately to Washington. Secretary of the Navy Frank Knox authorized the mission. Admiral Chester Nimitz approved. The authorization came back, get Yamamoto. The tactical problem was immense. Ball Island was 435 miles from Guadalcanal, where the nearest American fighter squadrons were based. Over open ocean, with no landmarks to navigate by, maintaining radio silence to avoid alerting Japanese radar, and needing to arrive at a specific point over a specific jungle airstrip within a window of minutes. The timing was the hardest part. Yamamoto was, above all things, punctual. The intercept had to happen within a very precise geographic and temporal window. Only one American fighter had the range to fly that mission. Only one American fighter had the navigation equipment, the P-38's internal radio compass, that might allow pilots to find a point in the middle of the Pacific Ocean after 2 hours of dead-reckoning flight at wave-top height. Only one American fighter could guarantee the speed needed to engage, destroy, and escape the Zero escort before Japanese reinforcements from Kahili Airfield could respond. Major John Mitchell of the 339th Fighter Squadron, 347th Fighter Group, was given command of the mission. He assembled 16 P-38s, stripped of their standard belly tanks and fitted with 165-gallon drop tanks to extend range. The mission profile was exact: fly from Henderson Field at wave-top height, 30 feet above the ocean, to avoid Japanese radar, covering 435 miles in 2 hours and 10 minutes of dead-reckoning navigation, arrive at the intercept point over Bougainville within a 1-minute window of Yamamoto's scheduled passage. Mitchell's navigation on April 18, 1943 was one of the most precise pieces of airmanship in the Pacific War. Flying at wave-top height in complete radio silence for 2 hours and 10 minutes, using only his watch, airspeed indicator, and compass, with no landmarks and no external references, he brought his 16 P-38s to within visual range of southern Bougainville at 0934, 1 minute ahead of schedule, exactly as the treetops disgorged 2 Betty bombers and 6 Zeros. Captain Thomas Lanphier and Lieutenant Rex Barber had been assigned as the attack flight. The remaining P-38s would engage the Zero escort. Lanphier and Barber split as the Japanese aircraft appeared. Barber got behind the lead Betty, Yamamoto's aircraft, and opened fire. His concentrated nose armament tore into the bomber's left engine and wing root. The Betty rolled left, trailed smoke, and crashed into the jungle south of Buin. Yamamoto was dead. The engagement lasted 4 minutes. The P-38s lost 1 aircraft, Lieutenant Ray Hine, shot down by the Zero escort. The cost was considered acceptable for what had been achieved. Japan's most brilliant naval strategist, the architect of Pearl Harbor and Midway, the man who had coordinated the most effective naval air campaign in history, was gone. And the manner of his death, shot down by fighters that had flown 435 miles across open ocean specifically to kill him, sent a message through the Japanese high command that no communique could have conveyed more clearly. Nowhere was safe. While Yamamoto's death rippled through Japanese naval leadership, American fighter squadrons were building the depth of experience that would make P-38 dominance systematic rather than sporadic. Richard Bong was emerging as the standard by which P-38 combat effectiveness was measured. Flying first with the 39th Fighter Squadron and then with the 9th Fighter Squadron of the 49th Fighter Group, which finally received its P-38s in early 1943, Bong refined vertical attack techniques to a precision that his contemporaries found difficult to fully explain. His gunnery was exceptional. He averaged fewer than 100 rounds per confirmed kill, compared to the several hundred that most pilots required. His situational awareness, his ability to track multiple aircraft simultaneously while managing his own energy state and position, was described by observers as something that couldn't be taught. He had internalized the geometry of three-dimensional combat in a way that let him see attacks developing before they materialized. By April 1944, Bong had surpassed Eddie Rickenbacker's World War I record of 26 confirmed victories, the record that had stood as the benchmark of American aerial achievement for a quarter century. General Douglas MacArthur personally awarded him the Medal of Honor at an outdoor ceremony at Nadzab Airfield. Bong, characteristically, said almost nothing, shook MacArthur's hand, and went back to flying. His eventual total of 40 confirmed victories, every one of them in P-38s, represented not just personal skill but a systematic demonstration of what the aircraft made possible. In one engagement over Hollandia in April 1944, he shot down 3 Japanese fighters in under 5 minutes, selecting each target from altitude, executing a diving pass, pulling up, selecting the next target, diving again. The Japanese pilots in that engagement had no answer. They couldn't climb to reach him between passes. They couldn't flee fast enough to escape his dives. They couldn't maneuver at the speeds he was imposing. They could only accept that they were going to die. Thomas Maguire, assigned to the 431st Fighter Squadron of the 475th Fighter Group, the first all P-38 unit in the Pacific, approached the problem differently but arrived at the same results. Where Bong was intuitive, Maguire was systematic. He studied combat reports with the intensity of a graduate student, tracking patterns in Japanese tactics, noting where American pilots had made errors, developing counters to maneuvers he identified as recurring problems. He wrote a manual, Combat Tactics in the Southwest Pacific Area, that became required reading throughout the 5th Air Force. Maguire's innovations extended the vertical attack doctrine in several directions. The Maguire roll, a high-speed barrel roll executed during the attack approach that confused Japanese pilots about the P-38's precise angle and timing, made deflection shooting more difficult for Zero pilots while preserving the attacker's momentum. The vertical scissors was a coordinated element tactic in which 2 P-38s alternated attacks and climbing reversals, trapping pursuing Japanese fighters between 2 threats at different altitudes, a 3-dimensional version of the classic weave that exploited the P-38's climb capability in a way no single-engine fighter could replicate. Maguire scored his first 3 kills on August 18, 1943, and his 4th and 5th 2 days later, becoming an ace in 3 days of combat. By the end of 1944, he had 38 confirmed victories, second only to Bong. On January 7, 1945, flying against orders, he had been told to rest. Maguire attempted to help a wingman being chased by a Japanese Ki-43 Oscar. He violated the fundamental rule he had spent 2 years articulating. He went low, bled off speed in a turning maneuver to get on the Oscar's tail, and his P-38, slowed and low on energy, was vulnerable for the first time in his career. A second Japanese pilot saw the opportunity. Maguire's P-38 spun in before he could recover. He was killed at 24 years old, 8 victories short of Bonk's record. His death was a tragedy and a validation simultaneously. He had survived 38 victories by following his own doctrine. The moment he broke it, he died. The doctrine was not a tactical suggestion. It was physics. The story of the P-38's dominance cannot be told only through individual aces and dramatic engagements. Behind the pilots flying over New Guinea and the Solomons was an industrial and training machine that was producing pilots and aircraft faster than Japan could replace what it was losing. Lockheed's factory in Burbank, California achieved production efficiency that Japanese industrialists could not have imagined in 1943. The P-38 required approximately 37,000 man-hours to construct, a figure that sounds enormous until you understand that American production engineering had organized those hours into a continuous flow that was producing 10 P-38s per day by March 1943. Monthly output exceeded 400 aircraft before the end of 1943. By the time American P-38 pilots were claiming 500 Japanese aircraft destroyed, Lockheed had already built replacements for every P-38 lost and had several thousand more in reserve. Japan could not do this. Japanese aircraft production, constrained by material shortages, aluminum, rubber, aviation fuel, all increasingly scarce as American submarines strangled the sea lanes, by bombing damage to factories, and by planning assumptions that hadn't anticipated the attrition rates the P-38 was imposing, struggled to produce 500 fighters per month of all types. Many of those were held back to defend the home islands. The arithmetic of attrition warfare, once it turned against Japan, turned inexorably. Training divergence made the situation worse. American P-38 pilots arriving in theater in 1943 had 300 or more total flight hours, including 50 hours specifically in P-38s. They had practiced vertical maneuvering, deflection gunnery, formation flying, and instrument flying. Some had flown against captured Japanese aircraft at evaluation centers and knew precisely what a Zero or Oscar could and couldn't do. They arrived understanding their aircraft's advantages and prepared to exploit them. Japanese replacement pilots were being rushed through training programs shortened from 2 years to 6 months, sometimes less. They averaged under 100 total flight hours by late 1943. Many had never flown above 20,000 feet before encountering P-38s in combat. Some had received minimal gunnery training. They were being thrown into combat against the most capable fighter in the Pacific, flown by some of the most experienced pilots in the Pacific, with a fraction of the preparation required to have any realistic chance of survival. The 251st Air Group, which had begun 1943 with 80 combat experienced pilots, had only 10 original members remaining by year's end. Not 10 in combat status, 10 surviving. The others had been killed, wounded, or invalided out with combat fatigue. The 204th Air Group lost 70% of its pilots in 6 months. The 582nd Air Group was withdrawn from combat entirely after losing 80% of its aircraft in 4 months of operations against P-38-equipped American units. American losses were sustainable in ways that Japanese losses were not. P-38 squadrons typically achieved kill ratios of 5-to-1 or better. American pilots shot down over friendly territory were often rescued and returned to combat. P-38s damaged in combat could be repaired using spare parts that arrived regularly by ship and transport. Japanese pilots who went down over water drowned in most cases. Japanese aircraft with substantial damage were frequently abandoned. Spare parts were increasingly scarce, and the manufacturing system that produced the aircraft was being systematically dismantled by American bombing. By December 1943, Lockheed had delivered over 2,000 P-38s to combat theaters. The arithmetic was irreversible. The months following Yamamoto's death saw Japanese tactical doctrine undergo the most fundamental transformation in the history of the Imperial Navy Air Arm. Before April 1943, Japanese fighter pilots had been taught aggressive engagement, to seek out American fighters and destroy them using superior maneuverability. The doctrine reflected genuine capability and had been validated by 13 months of successful air combat. After April 1943, instructions to frontline units read differently. P-38s were to be avoided unless the Japanese force possessed numerical superiority of at least 3:1, altitude advantage, and the element of surprise. Even under those conditions, engagement should be brief with immediate disengagement if the initial attack failed. Pilots were instructed that the P-38 speed made extended combat with it equivalent to suicide. This was not officially acknowledged weakness. The Japanese military did not use that language. But the practical instruction was identical to weakness. Do not fight this aircraft unless you have overwhelming advantages, and even then, be careful. The consequences extended beyond tactical adjustment. Japanese naval vessels, which had previously moved in daylight under fighter cover, began operating only at night. Supply runs to forward bases became desperate affairs conducted by submarines and fast destroyers in darkness. The Tokyo Express that ran down the slot to Guadalcanal rather than flying supplies through American-controlled airspace. Airfields that had once been active centers of offensive planning became defensive positions, their aircraft dispersed and camouflaged, their pilots waiting rather than flying. The Philippines campaign of late 1944 demonstrated how complete the transformation had become. When American forces landed at Leyte in October 1944, P-38 squadrons of the 49th and 475th Fighter Groups achieved air superiority over the beachhead within days. Japanese attempts to reinforce by air were catastrophic. On November 2, 1944, P-38s of the 49th Fighter Group destroyed 26 Japanese aircraft without losing a single Lightning. Such one-sided engagements had become routine enough that they barely merited individual mention in official histories. Japanese commanders responded with a desperate innovation that revealed how thoroughly conventional options had been exhausted. Special attack units, kamikaze pilots flying their aircraft into American ships rather than fighting the P-38s that protected them, represented a tactical acknowledgement that conventional air-to-air combat against American fighters was no longer viable. The kamikaze doctrine was not, as it is sometimes portrayed, a product of pure fanaticism. It was, in part, a rational response to the impossibility of fighting American aircraft by conventional means with the pilots and aircraft Japan had remaining. The F-5 reconnaissance variant of the P-38, nose cameras replacing the cannon and machine guns, ranged even further ahead of this equation. Flying at extreme altitudes above 35,000 feet, where Japanese interceptors simply couldn't reach, these photo lightnings mapped every Japanese installation in the Pacific systematically. The intelligence they generated enabled the precision targeting of oil storage facilities, airfields, barracks, and supply depots. The P-38 was not only winning the air war it was seeing. It was enabling the destruction of everything that sustained the Japanese war effort from Rabaul to Luzon. Between December 1942 and January 1945, P-38 units in the Southwest Pacific claimed over 1,500 Japanese aircraft destroyed in verified combat. American P-38 losses to enemy action totaled fewer than 200 aircraft, a kill ratio exceeding 7-1, unprecedented in sustained aerial combat at that scale. The numbers, though, miss something essential about what actually happened in those Pacific skies. The Japanese pilots who faced the P-38 showed courage that deserves acknowledgement. Flying aircraft that were being systematically rendered obsolete by an opponent they couldn't reach, continuing to fight long after the tactical situation had become hopeless, they persisted until there were too few of them left to contest anything. In post-war interviews, veteran Japanese pilots described the experience with a clarity that official after-action reports rarely captured. They spoke of the helplessness of watching twin-boom shapes diving from altitudes that their own aircraft, throttles full forward, simply could not reach. They described the frustration of executing perfect turning maneuvers that would have killed any P-40 or P-39 pilot who had made the mistake of trying them, only to find that the Lightning was already gone, climbing away at a rate their aircraft couldn't follow. They remembered specific pilots and specific engagements. They remembered friends who had survived China and Pearl Harbor and the Dutch East Indies dying over New Guinea in ways they still found difficult to articulate. American veterans remembered differently. They recalled the confidence that came from flying an aircraft that gave them the initiative, from always being able to choose when and whether to fight, from holding altitude that their opponents couldn't reach. They remembered the twin-engine safety over endless ocean distances, the relief of knowing that if one engine was damaged, there was another. They remembered the Allison engines running smoothly above 30,000 feet while their opponent's aircraft struggled to stay airborne at that altitude. They remembered, most of all, coming home. Richard Bong came home. He was pulled from combat after his 40th victory. General Kenney, his commander, felt that risking America's highest-scoring ace further was strategically irresponsible. He returned to the United States, married Marge Vattendahl, the girl in the photograph taped to every P-38 he had ever flown, and became a test pilot for the new P-80 Shooting Star jet. He was killed on August 6, 1945, the same morning the Enola Gay dropped the atomic bomb on Hiroshima, when the P-80's fuel boost pump failed on takeoff and the jet crashed. He was 24 years old. Thomas Maguire is buried in Manila. He never came home. The P-38 Lightning's legacy extended well past the Pacific War. The concept of vertical maneuvering, of using altitude and speed to control engagement parameters rather than relying on turning ability, became foundational to jet-age fighter doctrine. The F-86 Sabre over Korea, the F-4 Phantom over Vietnam, every subsequent American fighter design bears the conceptual DNA of what Kelly Johnson's twin-boom design proved in the Pacific between 1942 and 1945, that the pilot who controls the geometry controls the outcome, and the aircraft that controls the geometry is the one with the best combination of speed, altitude capability, and sustained power. Japan had built the Zero to win horizontal battles. America had built the Lightning to choose vertical ones. The choice proved decisive. The Japanese pilots had called it the twin-tailed devil. The name stuck because it was accurate. It couldn't be outrun. It couldn't be outclimbed. It couldn't be outfought above 20,000 feet. And once it found you, once those twin booms appeared in your rearview mirror at 400 miles per hour, the probability distribution of outcomes had already been settled. 7-1. Those were the odds in American P-38 pilots' favor, held over 2 years of sustained combat against some of the most experienced fighter pilots the world had ever produced. The math was not subtle. Neither was the lesson.